Hi, AP Statistics. We are going to go over Chapter 5, the Introduction to Samples and Experiments. So we're totally switching gears from least squares regression and talking about a completely new topic. So here are a few examples of how statistical studies are everywhere. The first one, the National Highway Traffic Safety Administration reports that seatbelt use in passenger vehicles increased from 83% in 2008 to 84% in 2009. Okay. According to a recent survey, U.S. teens aged 13 to 18 spend on average 26.8 hours per week online, although 59% of the teens said that posting personal information or photos online is unsafe. 62% said they posted photos of themselves. Okay, so what we're going to be looking at is how do we collect this data? How do we know that they sampled and found out 59% of teens? What teens did they talk to? Where did that come from? That's what we're looking at in this chapter. So can we trust these results? We're going to learn in this chapter. It depends on how the data were produced. So we have a couple main topics. The first one is going to be sampling. The second one is experimental design. So the first one that we're talking about is sampling. And let's see if I can... Okay, sorry, there it goes. Okay, so sampling. Suppose that we want to find out what % of young drivers in the United States text while driving. To answer this question, we will survey 16 to 20-year-olds who lived in the United States and drive. Ideally, we would like to talk to all of them, which is a census, but contacting every driver in this age group wouldn't be practical. It would take too much time and money. Instead, we put a question to a sample chosen to represent the population. So this chapter is a lot about vocabulary. So I would highly recommend making flashcards of your vocabulary words. They're bolded and are going to be really helpful for this chapter. Okay, so the population is the entire group of individuals about which we have information. The sample is part of the population from which we actually collect information. We use information from a sample to draw conclusions about the entire population. So now we're really going to be super specific about what is considered the population versus what is the sample. Okay. How to sample well. Many studies are conducted in order to generalize from a sample to the corresponding population. Okay, as a result, it is important that the sample be representative. Oops, sorry, I hit page down. Sorry. Be representative of the population. Okay, so this is what we are going to spend a lot of time probably discussing, analyzing. We want it to be representative of the population. So if we think about really quick, just like we'll talk about seniors at Oak Ridge High School. Do you think that our class, AP Statistics, is representative of the population of all seniors at Oak Ridge High School? Do you think that all the different types of students that we would have in the population, are those represented in the class of AP Statistics? What do you think about that? The answer is no. We have, in AP Statistics, we have students who are in an AP level math class. So those students are not going to be the same as every other kind of student that we have as a senior at Oak Ridge High School. So we wouldn't want to use our class, AP Statistics, as a sample to represent how everyone at Oak Ridge feels about a certain topic. Okay, because we may not have the same characteristics as the population has in our class. Okay, so we want our sample to be representative of the population. Okay, so the researchers must carefully consider the way in which the sample is selected. Most of the inferential methods produced in AP Statistics will be based off the idea of random selection. Okay, so randomness is going to be huge for this chapter. You're going to have to be able to describe how you collect random, how you do things randomly. We want it to be random, and why we do it randomly. Okay, so here's a few types of sampling procedures. These all yield a reliable sample. Okay, so these would all be fine ways to sample. There are some pros and cons to each of them, but they all can develop a good sample, good sampling techniques. Okay, the first one, simple random sample, we usually abbreviate that SRS, of size n, consists of n individuals from the population, chosen in such a way that each set of n individuals has an equal chance to be the sample actually selected. Or a sample that is selected from the population in a way that ensures that every different possible sample of the desired sample size has the same chance of being selected. Okay, so there's a couple key things to this, where every person and individuals has an equal chance to actually be selected, and also the sample is selected in such a way that every different possible sample of the desired size has the same chance of being selected. Those are the two things that are going to set the simple random sample apart. And we'll go into more detail as we go through more examples. All right, stratified random sample. First, divide the population into groups of individuals, which are called strata, and they are supposed to be similar in some way. Okay, so here is a big thing that students mix up. Strata. People in a strata are similar in some way. That's an important difference to the response. Then you choose a simple random sample from each strata and combine these simple random samples to form the full sample. Okay, example, stratified random sample. So if we have our class of AP Statistics, say I want to select a sample of 5 girls and 3 boys. My strata are the girls. Okay, so the strata are similar. I'm putting people who have similar characteristics, girls, together. And then I'm going to randomly select of the, whatever we have, 15 girls in the class, I'm going to select 5. Then I'm going to put the boys in a strata. Okay, so the boys, there's less boys in our class. I'm going to put the boys in a group, and then I'm randomly going to select 3 of the boys. So the strata, they're separated into the strata themselves. The people in the strata are similar. Okay, we put all the girls together, we put all the boys together. Then we take a simple random sample from within those groups. Okay, cluster sample. It divides the population into groups or clusters. Some of these clusters are randomly selected. Okay, so we randomly select a cluster. Then all individuals in the chosen cluster are selected to be in a sample. Okay, so example of that, cluster sample. So suppose the administration at Oak Ridge wants to somehow sample students. They want to get some information from students. What they're going to do is, which way to do a cluster sample, they're going to randomly select, say, a building at Oak Ridge. Okay, so once they select, maybe they select 2 buildings. So they select the I building and they select the R building. Then they're going to sample all the individuals who are, in there during second period. So every student that's in the R building, every student that's in the I building, they all become the sample. Okay, but the difference here is you randomly select a cluster, then you select everyone in that cluster. Okay, multi-stage sample. This you select successively smaller groups. Okay, smaller groups within the population in stages, resulting in samples, a sample consisting of clusters of individuals. Okay, so a multi-stage sample. Say administration again wants to randomly select students, but multi-stage means that you're going to randomly select multiple things. So in this case, let's say the administration randomly selects a department. Okay, so math, science, English, PE, social science, foreign language, arts. Okay, I think that's all of them. I don't know. I might be forgetting one. So say they randomly select one of those departments. Then they're randomly going to select a teacher. And then they're randomly going to select one of those teachers' periods. So say they randomly select math. Then they randomly select, Mr. Diaz. and then they randomly select one of Mr. Diaz's class, say first period. Okay, so then you're still then randomly going to select people from his first period class. Okay, so the difference between cluster and multi-stage, cluster usually you're only selecting, you're randomly selecting one cluster and then you sample everyone from that cluster. Multi-stage is you sample multiple times. So we're going to do a department, then you're randomly going to select a teacher, then one of their periods, and then the students. Okay, so it kind of goes down in a trickle effect. Probability sample. Sample chosen by chance. You have to know the samples are possible and at what chance or probability. Each possible sample, that's not a complete thought. Each possible sample has. So probability samples, so if we were going to select the departments, for example, we want to randomly select, say we want to randomly select 5 teachers. And so what we're going to do is look at the sizes of the departments. So math has one of the bigger departments. I think we have 17 math teachers, if that's right. So if I want to select 5 teachers, I might have, 2 of those be from the math department because the math department is so big. And then I'm going to have, maybe another 2 teachers from the social studies department because it's another big department. And then maybe 1 teacher from foreign language, 1 teacher from art, something like that. It's what you're doing is you're making sure that your probability sample is representing the probabilities of those departments. Okay. So yeah, it's in line with the probability or the proportions that you see in the population. All right, systematic sample. It's a procedure that can be used when it's possible to view the population of interest as consisting of a list or some other sequential arrangement. Okay, a value k is specified such that k equals 50 or k equals 200. Then one of the first k individuals is selected at random, and after which every kth individual in the sequence is included in the sample. Systematic sampling can work reasonably well as long as there is no repeating patterns in the population list. Okay, so say again the administration wants to sample students, and so instead of sampling classes, what they're going to do is there's an assembly on Friday and everyone's going to go to it. So they stand at the door and they're randomly going to select one person. So as everybody funnels in, everybody has to go through the doorways. They randomly select the first person, and then after that, they're going to sample every 25th student. So the first person's random, but then after that, say they select every 25th person. They keep taking the next 25th person, they sample them. Then the next 25th person, they sample them. So what it's saying is that this works reasonably well, long as there's no repeating patterns in the population list. So that means, what if, the whole football team walks in together? That's a large team. So you're going to have certain students who are going to be together from the varsity, JV, and freshmen. So that's like a cluster of students that they're not randomized. They're not all over the place. They're in a group. So that would be an error that could occur with systematic sampling. So you just have to watch out for that. Okay, so I'll flip the page. For these examples, decide what kind of sample was taken. So example 1, suppose you want a survey of opinions of AP Stat students to see if they feel they have enough time on the free response section of the AP exam. One option would be to begin with a list of all the schools that had students who took the AP statistics exam. A number of schools would be randomly selected from the list of all schools represented, and every student at the selected school who took the AP exam is asked if he or she thought the time allowed to complete the free response portion of the exam was adequate. Okay, so yes, there's going to be a lot of reading in this one. So we got to kind of figure out the key things. So a number of schools would be randomly selected from the list of all schools represented. Okay, so we randomly select, then what happens? Because we're doing another step. And then every student at the selected school who took the AP exam would be asked. Okay, Okay, they would be in the sample. So we randomly select and then we took everybody. What type of sample is that? That's going to be a cluster sample. Okay, because then every student was asked about the time on the test. Okay, example 2. To estimate the cost of malpractice insurance, a researcher found it convenient to view the population of all doctors practicing in a metropolitan area as being made up of 4 subpopulations: surgeons, internists and family practitioners, obstetricians, a group that includes all other areas of specialization. Rather than taking a random sample from the population of all doctors, the researcher could take 4 separate random samples, one from each group. These 4 samples would provide information about the 4 subgroups, as well as information about the overall population of doctors. Okay, so we separate the doctors into 4 groups, and then we're going to take a random sample. They're going to take 4 separate random samples, one from each group. What type of sample method is that? Okay, we separate them into groups that are similar. Notice the groups. The group of surgeons is supposed to be similar. The people who are in group 2, the internists and family practitioners, those are similar. Obstetricians are similar, and then the other areas of specialization. So we put them in separate groups that are similar. This is going to be stratified. All right, number 3. Mr. Sanders, my husband, decided to try a new strategy for his volleyball team. He decided to put each of the 14 girls' names on pieces of paper and pull them out of a hat. Then he randomly pulled out 6 names. Those 6 girls got to start in the next volleyball game. Okay, so everyone on the team, the varsity team, their names get put in. There's actually more than 14 girls on the team this year. And they randomly pull out 6 names. Those girls get to start. What would that be? This is a simple random sample. Okay, so every girl had the same opportunity to be chosen. They were just, all their names were put in a hat and they were drawn out. Okay, so they all had the same chance, a simple random sample. Okay, example 4. A sample of faculty members at a university is selected by randomly selecting one of the first 20 faculty members from the faculty phone directory. Then every 20th faculty member after that on the list is selected in the sample. Okay, so they randomly select one of the first 20 faculty members from the phone directory. Then they go through and take every 20th member after that. Okay, by doing that in a systematic pattern, this is called systematic sampling. Okay, when we sample, there are some bad things that can happen, bad things that can go on. So we need to talk about errors that can happen. So bad sampling techniques: a voluntary response sample consists of people who choose themselves by responding to a general appeal. Usually, this is biased, since only people with strong opinions, especially negative ones, are most likely to respond. Examples include responding to an advertisement, calling a publicized phone number to register an opinion, or logging onto an internet site to complete a survey. It is extremely unlikely that individuals participating in such voluntary response surveys are representative to the larger population of interest. Okay, it's going to be the extremes. Usually either people who are really satisfied with whatever the survey is talking about or really not satisfied and they want to voice their opinion. All right, a convenient sample. Choosing individuals that are just easiest to reach. They're just close by, and so that's what we're going to choose. Okay, it's an example of convenient sample. I'll say I just need a sample of 40 people to just discuss, I don't know, their feelings on the economy or their feelings on, the presidential election. So say I go just to the mall and I stand at the entrance or in the middle in the food court, wherever, and I just ask the first 40 people that come by me. That would be a convenient sample. Okay, for example 5 and 6, decide what kind of sample was taken. So example 5, the American Family Association, AFA, is a conservative group that claims to stand for traditional family values. It regularly posts online poll questions on its website. Just click on a response to take part. Okay, so they're on their website. Just click to respond if you want to respond to the poll. Would this be convenience, or do you think this is voluntary response? This one is actually going to be voluntary response. This is people who want to participate in the survey are going to participate. They're going to click and fill out the survey. So this is voluntary response sample. All right, example 6. Suppose we're interested in finding out how long students at a large high school spend on homework last week. We go to the library at nutrition and ask the first 30 students we see about their homework time. Okay, so we're just going to ask the first 30 students who are near us. That is going to be a convenience sample. All right, last example we're going to discuss. Example 7, former CNN commentator Lou Dobbs doesn't like illegal immigration. One of his shows was largely devoted to attacking a proposal to offer driver's license to illegal immigrants. During the show, Mr. Dobbs invited his viewers to go to loudobbs.com to vote on the question, would you be more or less likely to vote for a presidential candidate who supports giving driver's license to illegal immigrants? The result, 97% of the 7,350 people who voted by the end of the show said less likely. What type of sample did Mr. Dobbs use in his poll? Explain how the sampling method could lead to a bias in the poll results. Okay, so think about that for a second. Was he using voluntary response or a convenience sample? Okay, this is a voluntary response. They chose to participate in the survey because they went to his website and filled it out. So he used a voluntary response sample. So we're just going to write that down. Okay, voluntary response sample where people chose to go online to his website to share their opinion. Okay, so that's the type of response he used. But explain how this sampling method could lead to bias in the poll results. Do you think this is accurate then? The 97% of people would be less likely to vote for a presidential candidate who supports giving driver's license to illegal immigrants. Do you think that's true of the whole general population of the United States? No. Okay, why? He is talking to, who is he talking to? This is a, excuse me. He's known for attacking the proposal to offer driver's license to illegal immigrants. So during his show, people are already tuned in. They usually probably agree with his general ideals. That's why they're watching his show. So if you're tuned in and they tell you to go fill out a survey, you're already watching the show because you most likely already agree with this man. Okay, and so if you agree with his policies, you're watching his show. So this is just a very small portion of the population who already feel that way. Okay, so we can say that those who voted were viewers of his show, which means that they most likely supported his views. Okay, so what do we think about 97%? That's probably a huge overestimation of the percent of people in the population. Okay, not just his viewers, but in the population that would be less likely to vote for a presidential candidate. With this position. Okay. All right, so we talked about the introduction to different types of samples, and a little bit we started talking about problems that can happen with samples. So make sure you've got some flashcards going because there's going to be a lot of vocabulary this chapter. Thank you.